Alright, 65 Chevrolet C10 instrument cluster, and today we are fighting with the ammeter. It is combined with the temp gauge, and it actually comes out from the back. Oh, that is the thing. This one. It is an old school electromechanical magnetic coil-based meter.
Some theory. Old cars are simple. The main players are a battery, an alternator, a starter, and then, of course, all the whistles and bells consuming the power. Let's first ground the battery. Now we can install the heavy cable for the starter, and then wire the charging system. The alternator meets the battery at the junction point, typically located at the horn relay, close to the radiator. That point also feeds all the loads. I call this the main junction of the system. Now, when you hook an ammeter to the system, or how GM hooked the ammeter into the system, is basically the green wires here. It's connected between the main junction and the starter. The idea is to measure the voltage difference created in the charging wire when the alternator charges the battery. The starter cable has no effect on this because there's no current. The starter is not running, the engine is running. The green wires, or actually they are black and white in the real life, they pass the firewall twice, and there are a few points related to this. The ammeter circuit is always on, always hot. It's independent on the ignition switch. It's totally unfused, and it has a two-direction or dual direction power supply. You know, if there is a failure at the firewall, for instance, it will feed the current from both directions. Remember, the ammeter has very low resistance. Installing a fuse at the battery helps, but it will not solve the problem, since the failure point still gets a choice from the starter. I consider this a fire hazard. Old cables, old meters, etc. I would like to get rid of that, and the idea was that I will convert that into a voltmeter, setting up a whetstone bridge or something like that and measure the relative voltage around 12 volts in here. But as we can see in the next chapter, impossible.
Measuring. .3 ohms. It's definitely a current meter. I will hook up the the voltage supply directly to my ammeter. Absolute suicide thing. Never try this at home. Never try this at anywhere. It's here. I have my voltage set to 0. The current limit is on. I open the current limit slightly, and then I start to increase the voltage. You can see it's increasing 1 amp, and it's going to the current limit. It's about 3 amps for the full reading. Two and a half. And if I reverse the polarity, it will go to the other direction. So it's plus minus plus minus 2.5, 3 amps, something like that. Conclusion, it is a current meter, plus minus 3 amps. So, the reason for this study was to find out what an old GM ammeter is all about. In the internet you see comments like GM ammeter is safe because it is an external shunt ammeter and the work current never enters the cabin. Partly true, mostly true, but it is not just a sensitive voltmeter sniffing the charge wire. Measuring the charge current is a bit yesterday's news, more related to the old DC dynamos. A voltage reading would be a much better way for alternator diagnostics. My dream was to convert the ammeter to a voltmeter, something like this, but the 0.3 ohm internal resistance will clamp the bridge difference to 0, no matter what's the battery voltage. So my ammeter will stay there unconnected, just a decorative placeholder. If you have any ideas, please comment. Thanks for watching.